Hello everyone, welcome to this channel. This question is taken from Olympiad Pathfinder, Chapter 12, Build Your Understanding, question number 14. The question is, a charge Q is uniformly distributed on a thin rod of mass m and length L that stays at rest in free space initially. Two regions of uniform electric field of intensity E are created on both sides of the rod as shown in the figure. In the region of width L, where the rod is initially placed, there is no electric field. Now the rod is projected along its length so that it cannot enter completely into any of the regions of the electric field. Find period of oscillation of the rod as a function of the maximum distance xm entered by a leading end of the rod into a region of electric field. Let us solve this question. So this is the rod, thin rod, about which the talk is going on, and this one is having charge Q uniformly distributed over it. This region, this L length region, is a free space. There is no electric field in this place. The electric field starts on the right side from this boundary, on the left side from this boundary. And the electric field intensity magnitude is same for both the field, but they are opposite in direction. As per question, it is being said that it is projected along the length of the rod, but the rod is not completely entering into one of the field. So in practical, what is happening? Suppose you have projected the rod inside this field with a velocity v. So when it will start entering into this E field, it will experience a force in opposite direction to its motion. So gradually the speed v will decrease because of the retarding force, and it will come to stop when a portion of the rod xm completely enters into this field as per question. And then when the velocity becomes zero, but the force continue acting on the rod, so it will start pushing the rod again back in towards the free space, and it will come out since there is no dissipative force in the system, means energy is not getting lost, so it will come out with the same velocity from this field. Keep continuing with the same velocity and it will start entering into the second field, which is located on the left side of in the diagram. Again the same thing will happen since the E field intensity is same, so it will start experiencing the electrostatic force in this direction. It will slow down and maximum it will enter xm, because xm it entered this side when it was projected with the velocity v, and with the same velocity it is entering here. So this entrance of xm portion of the rod will be same on this field as well. But when it stops, still the force is acting in this direction. and it will push the rod back into the free space, and it will come out again with a velocity v in this direction. So basically the rod will keep oscillating. So let us catch a situation when x portion, x length of the rod has entered just into the E field on the right side. And we will calculate the work done from x, or for the movement of the rod from x distance to x plus dx distance. So what will be the force acting in this direction? Since x portion of the rod is inside, so x portion of the charge on it will interact with the E field, and dq, if dq is the charge on x portion of the rod, so dq into E will be the force that will be acting in this direction. Why? Because this rod is positively charged. So the force will be in this direction. So how can we express the work done? That dW, we can write this force into dx. Dx is infinitesimally small. So for practical purpose, we can take df as constant for this dx movement. So dq into E into dx, and you put the value of dq. Lambda, if we take the linear charge density on the rod, then lambda into x will be the total charge dq on it, on this portion. So lambda x into E dot dx will be the work done for the rod from entering from x distance to x plus dx distance. So if we calculate the work done from, or for the value x is equal to 0 to xm in this field, we will have to integrate the previous equation, that this way, for the x to be 0 from x is equal to xm, put the value from the previous equation, lambda x into E into dx, integrate it, you will be getting this expression, q into E into xm square divided by 2 into L, small l. Since there is no such force or the system within it which is transforming the energy into other form. So it is only a transformation of kinetic energy to potential energy. This potential energy is the work done that will store into rod. So we can comfortably write initially it was having a kinetic energy half mv square, that will be has completely now turned to potential energy because V is equal to 0 at x is equal to xm. So you will be getting V is equal to this much, q into E into xm square divided by ml whole bracket under square root. If you notice, the rod length is small l and the total free space length is L. So how much the rod will move from here to here? in this field. So that will be L minus capital L minus small l length in the free space. So distance covered by the rod in the free space, we can say that it is capital L minus L, and time taken for that, because in this region there is no force acting on the rod, so it will move with the same velocity, so we will get the time Tf. Tf is F is for the time spent in the field, L minus L by V. This time taken to cover this L minus L is Tf. Now, when the rod was x distance inside, and you have written the force equation for that dq into E, lambda x into E, so you can easily see that force is proportional to the displacement of the rod inside this field. X is the displacement, lambda is constant, E is constant. So this kind of motion is said, you must have read, is simple harmonic motion. So in simple harmonic motion, this constant part is equal to m into omega square, where omega is the angular frequency with which the rod will oscillate. So we will be getting omega as q e divided by ml square root. Time period we know will be 2 pi by omega, so we will be getting this much, 2 pi into ml by qe square root. What is this time period? This time period is like when, suppose the rod start moving from this point xm this way, so this much time, then it enter into here and move to xm, so this much time, then again back to here this much time, and then again from here to here. So this is your time period. So this you can visualize by assuming that both the fields are merged together and the rod is oscillating with this angular frequency inside these two fields. Now how much time, total time, the rod has spent inside the free space? One will be from here to here and the other will be from here to here. But from here to here is Tf, and velocity is same while going this direction or while coming back. So we can say 2 times Tf will be the time spent inside this free space by the rod. So total time in one oscillation will be T time, the capital T time spent inside the field, plus 2 times the 2Tf, that is total time spent inside the free space in one oscillation. So T plus 2Tf. Put the value of T and 2Tf and you will be getting the answer like this. So hopefully you understood the concept. In case of any doubt, please do write in the comment box. Go through the write-up. It will give you ease in understanding. Please subscribe the channel and hit the bell icon. Thank you.